Hello everybody, welcome to my channel and welcome back if you already subscribed. I'm very excited to make this TypeScript course that is going to cover all the important TypeScript topics that you need to know to go above the junior level developer. It is going to be perfect for developers that want to advance their TypeScript skills, but even if you're completely new to TypeScript, you can still stay for the first section and you will already understand the basic topics of TypeScript and you could already start working with that. So before we begin, I just want to say that most of the examples are taken from this TypeScript website. So if you already looked at it, you will be familiar with most of the examples here, but we're going to go through all of them and just explain the topics and everything to make it all clear. So before we start, let me just say that you can, of course, get this repository from my GitHub. It is already pushed and I will post the link in the description. So let's begin with everyday types. Okay, so before everything, I want to just say what is the motivation behind using TypeScript. So JavaScript is a dynamically typed language, and it's not going to throw you any errors until you run the application, so until runtime. So basically, you can do anything you want in your editor, and there won't be any errors until you actually run it. So let me show you just an example of the most common error that can happen in JavaScript. So let's say that we have kind of a variable here. So let's say const, let's call it just a variable, and it's going to be undefined. So this variable is undefined. So let's say that in JavaScript, I could do something like that. Variable dot name. And of course, now you can see that variable is possibly undefined, and we know that it's undefined. But if we were in the JavaScript world, in the JavaScript file, this thing would never cause an error. So the motivation is to prevent errors. Of course, you have some other benefits. When you work with teams, you have a good understanding of what everything is doing, what every function is, what every variable is. And of course, you can prevent errors and you can make the developer experience much better when you have the type autocompletes and everything that you will see actually later. So this was in short just some motivations for you to use TypeScript. And now we can actually begin with the explanations. So let's go through some basic primitives. So we have in TypeScript strings, numbers, and booleans. These are very straightforward. So you can see that we can declare variables and just add them a value. And look at this. We have this some string over here, which says hello world. So TypeScript knows that this variable is going to be a string. And this means that if we take this variable, some string, and we want to do some stuff related to string types, so we can say some string at position 0, and of course it's going to print us the age over here, because the age is at position 0. So what I want to say about that, so if we delete actually this dot at, and we say dot, and now we can have all the autocompletes that we can do with strings. So if I go down over here, we have this add thing, we have char add, char code, all this stuff, slice, start with, substring, string. Basically, I don't even need to go to the docs to see what I can do with strings, because everything is just autocomplete for me. So let's get back to what it was. So again, everything is going to be the same with numbers and with booleans. So let's say that if we have this boolean over here, so some boolean, and of course we cannot say at position 0 because this is not a string and this is not a valid code. So let's see the error. Property at does not exist on type true. All right, let's continue. So another thing that we can do is to annotate the variables. So instead of just saying that my name is Alice, I can say that this is going to be a string. So this is how we define, even though TypeScript already knows that this is a string, we can just define it like that. Array. So in array, we can define it in two ways. So the first thing we can use this bracket notation, and we can say that, for example, array of strings. By the way, this is a type, and type is something that we can define as a type. So this thing, array of strings, is going to be type of string array. So basically, we can assign this type to a variable, and this variable should be array of strings. Another way that we can define arrays is by this array interface. And this is going to be array of numbers type, because even you can see that if I hover over this, this is going to show me that this is a number array. And here, if I hover over this, it says that interface array, and you can see this T over here inside. So we're going to talk a lot more about generics in the future, but just to make you know, this is a generic thing. So if I pass here a number, it's going to be, this T is going to be a number. If I pass here an object, so let's say ID string. So now this T is going to be this object over here, and this is going to be an array. It's not going to be an array of numbers, of course, it's going to be an array of objects with ID string. So let's go back. And now let's see that how we're going to use this array stuff. So if we have some array and we have hello world inside of that, we can see that some array is going to be array of strings. TypeScript can just know it by the value over here. And now we can see the use of array of numbers. So just as we defined here that this variable is going to be a type of string, we can say that this variable is going to be type of array of numbers. And basically it's going to be, I don't have the annotation here. Here we just say array of numbers, but here we can see number array. Okay, tuple is a little bit not advanced, but it's not. Let's say the juniors are less familiar with that. So let's say that we want to have an array which is going to have only two things: a number in the first position and a string in the second position. So employee is going to be type of, you can see that now, not going to be type of numbers or arrays, because the type here is array, number, and string. So this is a valid thing, but if I want to add here something new, hi, so now TypeScript is going to complain because it doesn't suit the type that we defined. And you can see, let's actually get rid of this hi. I want to show you something. Yeah, so I wanted to show you something, but I don't see it here because I thought that we are going to see a read-only type, but let's continue and we will see it in a moment. So let's say another example here that if you're familiar with React, you know that there is a tuple for use state. So basically we get the value and we get the function of set state. It's not actually going to work like that because it's much more complicated, but you can see that we have here a state, which is a string in my example, and we have a tuple here. And look at this. Now we can see that this is a read-only. So we have an array, and the first argument for now it's empty string because we defined it for the default like this. And the second element is going to be a function that takes a new state, which is a string, and returns a void. We still didn't talk about functions, but you probably can guess that this is a function by the syntax. And look at this. So the second one is a function, set state, and it's going to take a new state as a string, and it's going to set the state to this new state. And the key thing over here is that we say as const. So this is another way that we can define it as a tuple, because when it's as const, it's going to be the read-only array, and we cannot change this array over here. So if we try to look at this code, we're trying to push something to the tuple example variable, and this is not going to work. So the error is property push does not exist on type read only. So yeah, so basically this is it. And if we remove this as const thing over here, now look at the type of this tuple example. So it can be a string or a function that takes a string and returns void. So basically we still haven't talked about it, but this is a union type, so this can be or this or that. And to actually prevent this from happening, I have to say as const like this. Okay, let's talk about the any type. So any type is basically saying I don't care about the types. So if I define this object, so let's say this variable is any type and x is going to be 0 inside this object. Now look at this. None of the following lines of code will throw compiler errors. Using any disables all further type checking, and it is assumed you know the environment better than TypeScript. So it's not recommended to use any type. It is just the same as using just regular JavaScript. So we can say object.foo and it's fine. We can just call the object. We can say object.bar is going to be 100, object is going to be hello, const n is going to be a number. We can assign this object. So it's a mess. You can do anything that you could do with JavaScript if you define something as any. Later, we're going to see a better alternative to any type. I will give you a spoiler, which is an unknown type. All right, functions. So parameter type annotation. We can say that this is a function which is called greet, and the name here is going to be string. So now when we are inside this block, TypeScript knows that name is a string, and we can do all the things that we can do for name variables. Okay, now if we try to pass something that is not string, of course we're going to have an error. So grid42 is going to be an error because argument of type number is not assignable to parameter of type string. Very straightforward. And we can also define the return type annotation. So get favorite number, it's going to return a number. So this is how we say what we want to return. So if we return something like, this, type string is not assignable to type number. Cool. No type annotations here, but TypeScript can spot the bug. So we have names, Alice, Bob, Eve, contextual typing for function. So we have names for each, and here we have each name, and s.to uppercase, and of course this is a bug, there is a typo here, so there is not such thing as to uppercase, so it says property to uppercase does not exist on TypeScript. Did you mean to uppercase with a big with a capital C? So another cool way to prevent bugs just from typos and stuff like that. Now let's talk about objects. The most classic example is to have an object which is a point, and it's going to receive x and y, which both of them are going to be numbers. And basically, so basically the function is going to print the coordinates for x and y. And here are we going to use this. So print coord, and x is 3, y is 7. This is a legit code. Everything is clear. And now let's talk about optional properties. So this is an important thing. So print name is going to be, it's going to take an object with a first and last name, first and last strings basically. And now let's look at this last thing over here with the explanation mark. So if I hover over this, you can see that the last is going to be string or undefined. This is how we specify optional properties. And now let's look at the code. Print name first Bob. So we didn't supply the last name, and it's still fine because it can be undefined. And first and last is also fine because now both of them are strings. Okay, union type, we already talked about it, but here we have print ID, which is going to take an ID, which is going to be number or string, and it's going to just log it like this. So this is fine, we pass in a number, this is fine, we pass in a string, and this is not fine, we passing an object, which is not defined over here. So a quick example of working with union types. This is not part of narrowing, but later we will see much more stuff. So here we take an ID, which is a number or a string, and if type of ID is equals to string, so we have a check here, which is going to return a boolean. And basically, if this is true, then we want to execute this code, ID to uppercase, else we just want to log it. So in this case, ID is going to be string type. In this case, ID is going to be a number type. TypeScript is smart enough to know that if it's not in this block, it's going to be the other type. Let's see another example. So another function, which is going to take an array of strings or a string. So if array.isArray, so if this parameter is array of strings, so basically we check on x if it is an array, and here x is an array of strings. So we can do this log like this. So hello x.join and blah blah blah. And here array is a string. So just another way to check if something is an array, is a type of array. Now type aliases, so we can define a type of point. This is the same thing that we did with the previous function that prints the coordinates, but here we define the type over here. It's going to be an object of x and y, and here we can assign this argument to the type of point instead of writing the object over here. Now let's talk about interfaces. So first question is arising, why should I use interface and why should I use type? There is a lot of arguments about each of them, so I'm not going to go into it, but just a general thing from me. Just use interface whenever you can. When you can't use interface, just use type. What do I mean by that? You cannot say interface equals string or something. In this case, just use type. If you're working with React and whatever, I don't know, backend or stuff that you're doing, but in React, when I define props, I define them as an interface usually. So the syntax is pretty much the same, that only difference is here we have point equals and here we don't have this equals thing. So let's talk about what is extending an interface. So let's say that we have an interface which is animal, and animal is going to have a name and a type. And let's say that here we define another interface based on the animal. So interface bear is going to extend animal, and it's going to have another property, honey boolean. So basically this extends thing, you can think about it extends all the properties that animal have and adding also this thing. So now bear is going to have a name, it's going to have a type, it's going to have honey, property, whatever. This is a weird example that they give, but let's go with that. So we can define a bear, and we can say that this is going to be a bear interface, and you can see that his name is Pooh, the type is bear, and honey is true. And of course we can and of course we have access to all these things. So we can do the same thing with types. So let's say animal type is going to be name of string, and bear type is going to be animal type, and this thing, so honey boolean. So same thing, just another way. So you can extend types and you can extend interfaces, and this is the difference, the syntax difference. So type assertion, you already saw that we used it for the sconst, but we can also do it. So let's think that we are inside the JavaScript browser environment. So we have a document, get element by ID. So let's say that we have some kind of canvas and we want to say that this canvas is going to be as HTML canvas element. So we can just assign it to the type. So we can assign it to types that we didn't create, and we can just assign it to I don't know, types that we already created. All right, the next thing, literal types. So we can actually define a variable, and we can say that this variable is going to be of type hello. So this is pretty interesting because this variable actually cannot be anything else besides this hello string. So this is okay, but this is not okay because let's see, the error type word is not assignable to type hello. It's pretty strange, but this actually exists. So you can see here a real example of these literal types. So let's say that we want to print a text. We have a function that takes a string and alignment, and the alignment can be only left or right or center. And of course, this is going to be fine. We pass hello words string, and the alignment is going to be left. But if we have some typo over here, type center is not assignable to type of left or right or center. So this is very useful when you want to have some constant values. So we have another example here of numeric literal types. So the return type of this compare function can be or -1 or 0 or 1. And basically we are comparing A and B, and we're returning one of these values depending on the result over here. Now here we have another example of actually using interface. So we can have an interface which is going to take the options interface, and it's going to include the width, which is a number. And we have function which is configure, and X can be or options or auto. So we can say configure with 100, configure auto, configure automatic is going to cause an error, of course. And the next thing that we're going to talk about is null and undefined. So first of all, just for general info, null and undefined are going to be false types. So they're going to contain false values. So let's say over here, we have a function do something, x is going to be string or null, and if x is going to be equal to null, I'm going to do nothing. Otherwise, I'm going to do hello with the x that we passed. Now, this is a very important thing. So let's say that we have an x, which is going to be, first of all, you can see that this is going to be optional. We can already see the type if I hover it. So number or null or undefined. So it's adding the undefined because it's an optional. And what we can do is we can say console log x, and only if it's going to exist, we're going to do toFixed. So basically this exclamation mark is going to check if this x is going to be a true value. So if it's null or undefined, it's not going to execute this toFixed. And this is totally fine because the only time that x is going to be defined, it's going to be a number. So we can do this toFixed function over here. Now enums is something that is not recommended to use because it's, first of all, it's not performant. Second, you don't actually need them. But just a quick note, there is something that is called enum. And let's look at some interesting moments over here. So we have enum of direction. And look at this weird thing. If I hover over this, direction.north is going to be equals to 0. And it's the next one is 1, 2, and 3. Now, let's say that we have a player direction, which is going to be type of direction. And I'm going to assign it to direction.north. And if we console log this, player direction is going to be output as 0. So this is if we have some kind of options and the options are we want to specify a set of options, we can just use this enum and just check. Yeah, we can actually even check if direction north is equals to directions east, but it's, of course, it's never going to happen. But anyway, I'm not going to talk too much about enums. I actually haven't used them that much, and even when I wanted to use them, for my fortune, the senior developer told me to not use them. So anyways, this is it for everyday types. This was pretty long section, but covers pretty much all the basics. And the next thing is going to be much more interesting, narrowing. So I hope you enjoyed so far, and we will continue with narrowing on the next section. All right, so very important topic, narrowing, and we're going to talk about, this one is going to be also pretty long one, but it's very important to understand because it's very day-to-day usage. So let's first of all, let's see some type of type guards that we have. So if we check a type of something, it can be string, number, big int, boolean, symbol, undefined, object, function. We can use this type of stuff to check our variables. So for example, a usage of that hello. So console log type of hello going to be, of course, string. So let's see. So we have a function padding left, and we already saw examples like that. So we have a padding which is going to be number or string, and the input is a string, and we can check the type of padding. If it's a number, then we're going to do this thing over here. I'm going to actually append these empty spaces. Otherwise, we're just going to, in this case, padding is a string, and input is a string. So we're just going to return both of them together. Now, truthiness narrowing. So what that means that all the values that are falsy. So for example, in JavaScript we have undefined and null. Also, the number 0 is a falsy thing. So if we have this get this function get users online message, and number of users is going to be a number, and we can check if number of users. So of course this is going to be a number, but in case that number of users is going to be equals to 0, it is not going to do this thing. So it's just going to return nobody is here because because 0 is actually a falsy value. So there are actually some examples for falsy values. So let's see, 0 not a number, empty string, 0n is the big int type, and yeah, so 0 version of big int, null, undefined, and false. So another way to check falsy value, like to check Boolean values, if we do it with this Boolean constructor. So if we pass hello, type Boolean value true, and because hello is a true value, and we can also check like this. So 2 exclamation marks, word is going to be type true, value true. So what this thing is going to do, I think it's going to convert it to Boolean of true or false, and it's going to return if it's true or false. So basically it's going to convert this word string to true. Yeah. So let's go to the next one. So here, let's see. So we have a print all function, and strings is going to be a string or a string array or null. So what we need to check here is we need to check if string actually exists. So this is checking if strings is not a falsy value, so not null, and the type of string is an object. So that means that it's going to be the string array, so array of strings basically. So now we can do for off, and we can console log all the strings. Else, if type of string is going to be a string, we're just going to console log the string. So look at so something interesting to note here. We don't check here. We can just check if this is an object, and if we check the type of array, it will be an object. So some weird stuff. We don't have an array type of over here. So if we do type of array, so let's say something like that, type of array, I don't know, it can be even empty, but this is going to be actually type of, the print is going to be type of object, which is very strange, but it's JavaScript, so I'm not surprised. Where were we? Here we check if it's an object. Now the type of this thing is going to be a string array, because this is the only option that we have for object type. Now, if I add here this object over here, now we're going to have a problem. So TypeScript is smart enough to know that this can be an object or an array of strings. So this is not going to be valid code. We need to check if it's explicitly an array. So let's delete this thing. So equality narrowing, TypeScript also uses switch statements and quality checks like equals, not equals. This is a weak equal. Yeah, so basically we can use all of this stuff. So let's see at this example. So x can be string or number, and y can be string or boolean. So what is common between these two variables is that they both can be a string, right? So if x is equals to y, that means that they're a string, because there is no any other options that this thing is going to be true. We can now call any string method on x and y. Yeah, so it's like I said. Else, I just want to console log them, because else that means that they're not equal, so it can be any possibility. So let's check this thing. X can be string or number, and y can be string or boolean. Yeah, so makes sense. Yeah, so another example of the code that we saw before. So we have this thing over here that we checked if strings is a true value and its type of object. Over here we can see that we check if strings are not equals to null. Inside this if statement we have all this code like this. So just another option. Now another way that we can check for true values is inside objects. So let's say that we have this interface container, and it's going to have a value, and the value can be number or null or undefined. and multiple value is going to take the container, which is going to be the container interface, and factor, which is going to be a number. And by this check, if container.value, we already remove both null and undefined from the type. So basically here we can do the container.value multiple equals to the factor that we want to multiply it. Okay, very cool stuff is the in operator narrowing. So let's say that we have two types of fish and a bird. So fish can swim, which is a function, and bird can fly, which is also a function. So let's say we have a function which is move, and it takes an animal which is a fish type or a bird type. Now look at this check. If swim in animal, so we check if this swim field exists in the animal. If it has a swim property, that actually means that the animal is type of fish. So I can do animal.swim. Else I can do animal.fly because now the animal is type of bird. So how cool is that? We can actually check properties inside these types. Now there is another example of it, but here we also add a human, which can also swim and fly. Yeah, very strange stuff. But anyways, now if we check swim in animal, so now it can be fish or human. So this is not actually helpful. So now you can see the TypeScript cannot know what is the animal. So it can be either fish or human, even though in human, swim is an optional field, so it can be undefined. But still, TypeScript assumes that it is possible for human to have swim, and this is why it cannot tell us if it's a fish or human. And the same thing for bird, because the human can also fly. Now, another method of narrowing is instance of narrowing. So let's say that we have a function that gets the x value, which can be a date or a string. So if x instance of date, that means that I can use all the properties of the date constructor. So here I can do x.to UTC string, and it is totally fine. And else we do x to uppercase. Now let's see the assignments. So x2 is going to be map.random, and if it's bigger, if it's smaller than 0.5, then it's going to be 10. Otherwise, it's going to be hello world. So let's look at this type. So TypeScript can tell us that it can be either a string or a number. So if we say here x2 is going to be 1, which is totally fine. x2 can be goodbye, which is totally fine. Yeah, and we can of course console the value, and every time it will change. And of course we cannot assign it to anything else other than string or a number. So this type is actually defined by just by randomness. So TypeScript can tell us that it's possible that it can be a string, it's possible that it can be a number. So this is why this type looks like this. Okay, another very important thing is type predicts. And this is a very useful utils functions. So let's say that I want to have a function which is going to be isFish. And what I want to return from this function, first of all, I want to get a pet, which is a fish or a bird. And I want to say pet is fish. So what I'm doing here is I'm saying that pet is fish. And I'm running and I'm accessing the swim property. And if it's not going to be undefined, that means that the pet is fish. just like the function returns says. So let's see an example of how we can use it. So let's say that we have this function get small pet, which is going to return a fish or a bird. So imagine that this gets a random pet. We're not going to do this code actually, but now we have this variable which is zoo, and zoo is going to be an array or either a fish or a bird, because get small pet can return me a fish or a bird. And now I want to filter with this variable, so underwater is going to return me an array of fish. So we're going to use this helper function that we created. I'm going to do sudo.filter, and I'm going to use this isFish function. So is fish, so it's going to return me a boolean if the pet is fish. So if it's true, it's going to return it true, otherwise it will return false. And basically with this isFish check, we are checking if each pet that we are getting have the swim property. We're returning if it's not equals to undefined, basically. All right, now let's look at discriminating unions. So let's say that we have an interface of type shape, and the thing that is important here is that I want to use this kind, which is a circle or a square. And we have the function handle shape, which is going to take a shape. And now we check if shape.kind equals to rect, which is not part of this shape, then it is not possible. There is no overlap between circle, square, and rect. So it says that it has no overlap. So this check can never be true. So the next function we have get area, which is going to get a shape. And now I want to check if shape.kind is a circle. I want to say math.py. Basically, I'm just calculating the area of the circle in this case. So still TypeScript complains because radius is an optional and it can be undefined. So a very bad solution that they provide here is to use this exclamation mark in the end. And you can see from the comment that this is going to tell TypeScript that this value actually exists, but still cannot know it. So it can actually cause bugs in our code, which is not ideal. And of course, we can see now the proper solution. So of course, radius has to be a number and not an optional. And we have interface of type circle or square. Now shape is going to be this union type, circle or square. And get area is going to take the shape. And we have here a switch statement. We could also do it with if statements. It doesn't really matter. So in case of a circle, we are checking the shape.kind, and in case of a circle, we're going to calculate the area, and in case of a square, we're going to calculate the area like this. Now let's talk about the type that we haven't talked about yet. So this is the never type. So let's see the executiveness checking with the never type. So the never type is assignable to every type, however, no type is assignable to never, except never itself. This means you can use narrowing and rely on never turning up to do executive checking in a switch statement, for example. So adding a default to our getArea function, which tries to assign the shape to never, will raise an error when every possible case has not been handled. So let's look at this. So we have a shape, which is a circle, square, or triangle. So get area is going to be again a switch statement, but this time we have a default over here. So if we get to this default thing, I want to assign the executive check to never, which is going to be equals the shape. So look at this. It's very interesting thing. So actually we have checks for circle and for square. Now let's look at this shape variable. So in this case, shape is going to be a circle, and in this case, shape is going to be a square. Now let's look at the default one. The default is going to be triangle because we didn't do any case for triangle, and we can actually pass the triangle over here because we define this interface, kind is triangle, and we can possibly we can have this triangle passed to this function. So let's see what the error actually says here. Type triangle is not assignable to type never. So if I do this thing, this is totally fine, but we have an error here because we are not handling the triangle case. So let's go down here and let's say that we have a case, and let's say you can already see that I have autocomplete for the triangle possibility. So we have a triangle, and let's say that I want to return I don't know, I am triangle. How do you type this? Triangle. So now this thing is satisfied because we have covered all the use cases, and the default one is can actually never happen. Right, guys, before we move to functions, just another classic example of when we can use the never type is if we have a function that throws an error. So basically, the default thing that it does is throwing a new error with the error message. And you can see that I'm able to type this as never type because it's actually never going to return anything. So it's in this case, it's not a void, it's a never. Okay, now we're going to move to the functions section. And in this one, we're going to go more deeply into functions and the possibilities of typing functions, and just a little bit more complex stuff that we can do with types for functions. And also there are going to be some generics introduced in this section, but don't worry, there won't be anything complex. We're going to talk about generics more in the generics section part. Okay, so function type expressions, nothing new here. We can define a type, which is going to be equals to a function. And in this case, a is going to be a string and it's going to return a void. And now we can define another function and we can pass this function that we defined. So fn is going to be the greet function, and we can invoke it inside the higher order function just like this. So we are using the fn that we passed, and we just pass the hello world string to this function. So here is the usage. We can just define a function, print to console. It's going to receive a string, and it's going to console log the string. And here we use this greeter function, and we pass the print to console function. And TypeScript is satisfied because this function is exactly the same type as we defined here in the greet function. Now let's talk about call signatures. So we can define a type, for example, describable function. So it's going to have an argument. So it's going to have a parameter of description, which is going to be a string, and another function. So here you can see that I'm defining this function like this. So it's going to take some argument, which is type of number, and return a boolean. So the usage of this, so let's say that we have a function of do something, and we pass the fn over here, and fn is going to be the describable function that we define. And we can do this because we didn't describe it as some type of field. So if we describe it, for example, let's say that this is a field, and this is going to be a function like this. So now we have an error because we are not passing here the type like this with a function that is called field, and then we are invoking it. We are just going to invoke it like this by default. So this is the function itself that is being passed as the fn. I know it's a little bit confusing. I personally haven't even used it in the real world examples, but just for you to know that we can make a call signature like this. And now what we can do is we can define this my function as a function, and we can and we're going to pass some argument which is going to be type of number, just like just like this type, and it's going to return a boolean. So we're going to check if the sum arg is bigger than 3. So it's going to be either true or false. And of course, you can see that this is returning a boolean. And now what else we can do is we can say that myfunc.description is going to be default description, and this is going to satisfy this description string over here. And now we can use this do something and pass my function, and nothing is going to be broken because we have the description, and we're calling the myfunc function, which is going to get a number, and it's going to return a boolean. So yeah, I know it's confusing, so let's look at it again. So do something is going to receive fn, do something is going to receive my function, and my function is going to be this type over here. And basically we are just passing the number value over here. So fn is called over here with the number 6, and the definition of the function itself is defined here in the type. I hope you understand it. It's a little bit complex to explain it. So let's move forward to construct signature. So this is just another way to define function types. So let's say that we have some object, which is an object. We have some constructor, which is going to be new. And you can see that this is a function. So it's going to receive a string and return some object. All right. So fn is going to take actor, which is some constructor, and it's going to return a new actor. So this is a function, and it's going to get a string of hello. So this is just another way to define this function signatures, and this one is called constructor, and as I said before, the other one is called signature. Okay, let's move to the interesting part. So it's going to be a little bit touch on generics. So generic functions. Generics will be explained deeply in future lectures, as I said. But let's look at the example over here. So we have a function that is going to return the first element of an array. You can see first element is going to take an array, which is any type. So this is not a good practice because we don't want to use any. And if we look at the type of this function, you can see that it receives an array of any type, and it returns any type. So a quick fix that we can do over here is we can pass a generic. So look at this function, first element with generic, and we define the generic type over here. So we can call it type, we can call it t, just however you want to call it. And now we can use this type that we defined to say that the array is going to be an array of type. So the type that we are passing to the function is going to be the type over here. So what this function is going to return is going to return either the type, because this is just a singular type from the type array, or undefined, if in case that the array doesn't have any length. So basically it doesn't have anything in the position 0. So let's look now let's hover over this function, and we can see just what we defined. We're going to take a generic type, and the array is going to be a array of an array of type, and it's going to return type or undefined. Now let's see on some examples. So we have this variable s, and we use the first this function, first element generic, and we pass an array of strings. All right. So now TypeScript knows that the type of this function is going to be string, because we passed an array of strings. So we can see here array is going to be array of strings, and it's going to return string or undefined. And beyond that, even if I hover over this, I can see that this s is going to be either a string or undefined. And of course, we have the same example for numbers. So here, instead of string, we are getting the generic type to be a number. This is going to be a number array. It's going to return a number or undefined. And now let's look at this empty array. So here, it's very interesting that the generic is going to be never, and it's going to be an array of never, because we don't pass anything actually to the array. And you can see that I'm returning undefined, because the array is empty. So now let's look at u, and u is undefined. Look how amazing it is. All right, now let's look at the inference example. So as you can see, we are not limited to only one type. We can pass many generic types over here. So you can see here that we define a function that is called map, and we pass an input and an output types. So this function is going to receive an array, and it's going to be input array, so array of type input, and it's going to receive a function, and the argument that the function is going to get is going to be type of input. So remember, this is still the generic type, and it's going to return an output type. So we basically are returning here the generic output. And what the map itself is going to return is going to return an output array. So you can see here the return of this function is going to be array.map. I'm going to use the regular map from JavaScript, and we're passing the function over here that we passed to our map function. So now let's look at some examples. So parameter n is of type string. Parsed is a type of number array. All right, let's look at what we are getting here. So first of all, let's look at the map thing over here. So let's look at our types. So we're passing string, number, array is going to be string array, and the function is going to receive a string and return a number. And in the end, it's going to return an array of numbers. So if we hover over this n, you can see that n is going to be a string, because it infers like the input type. See over here, input type is going to be generic, which is going to be the type of this array. So array of strings, so the single one is going to be type of string. And we are doing here a parse int, which is going to convert a string into an integer. So what is the type of n over here? So it's still a string, but I know that it's going to take the string and return it to a number. So basically, if I hover over this parsed variable, and see that it returns a number array, just like the output of our map function. So output array is going to be the output of basically of this thing over here. So basically this thing, parse int, and we're passing the n. So I hope it makes sense. It's just taking array of strings, converting them to number with our function, and it's going to return an array of the outputs. Now let's look at constraint values. So this object, this example is a little bit confusing, but let's go through over this. So we have a function that is called minimum length. And what we do here is we're actually getting again a generic type. And this time, this type is going to extend the object that has a length, the length property. So basically, length property is going to be a number. And what object in JavaScript have a length property? Array. We can do array.length and get the length of the array. So basically what it means is that this type is going to extend an array type, which is confusing by itself, but let's look further. So we receive the object, which is type of type, and we have a minimum property that is going to be a number, and it's going to return a type. And this is already incorrect from what I see, because if the object.length is bigger than the minimum, then I'm going to return the object, which is fine because object is type of t, which is extends this this length number thing. But yeah, it's fine because I'm returning the type, but else I'm not doing anything that is related to this function. So let's maybe try to return, I don't know, undefined or something. And let's maybe try to say that this is going to be a union with undefined. And cool, now this function, now it's more properly, yeah, this example is actually more defined, because now it makes more sense, because we want to check if this array actually has the minimum length that we want, and else we don't want to return it, but I want to specify here that it can actually return undefined. So now let's look at this. So array, I'm passing here this array, so 1 to 3, and of course it's not going to be not going to have a bigger length of 6. So in this case, what we can get from here is number array or undefined. So only if the minimum is bigger, only if the length of this array is bigger than the minimum, then I want to return this array back. And now this thing is going to be crushed, because array can be undefined, and I cannot use this slice method on something that can be potentially undefined. So a very quick fix is just to add here an exclamation mark, and now only if this is going to be a truthy value, then it's going to run this slice method. Now let's look at specifying type arguments. So this one is an interesting thing. So if we have a function which is a combine, which is going to take a generic type. And I can see here that I'm getting two arrays as arguments, and I'm going to return the array. Basically, it's going to take the same types for this array and for this array, and it's going to return the generic type array. So basically what we want to do with this function is to combine array1 and array2 with the concat method. And here you can see the error that we get. So let's look at this. Combine, and we are passing array of numbers and array of string. So let's look at this. Type string is not assignable to type number. This is because this generic already assigned as number, because I think it happens because it already makes the decision on the first type over here. So let's look at the array. So it says that it returns array of numbers, but we can actually override this error by specifying that the type is going to be a string or a number. And now we can use this this function properly. And here, if we check the type, it's going to be a type of or a string or number array. So basically, when we are using this function, we are specifying what this type is going to be. So optional parameters, we already talked about it. So we have a function which can receive a number, and if we pass here an optional, so it can be a number or undefined. In this case, both of these use cases are fine. So there is nothing new over here. Now let's look at another example. So here also we have a callback function. There is also a generic type over here, generic array, and the index can be optional. So what we can do here is we can call it with a as a number, or a and I as an index, or sorry, as a number or undefined. And again, both cases are totally fine. Now let's look at the unknown type. So as I said before, if we pass any, so everything is fine. So it's just like regular JavaScript. So a.b is totally fine, but if we instead we use unknown, so let's say that we have a function and we pass a as an unknown, we cannot do something like that because a is type unknown. And when we use unknown, we have all the type safety that we get from TypeScript instead of using any type. So let's look at some examples. So safe parse is going to receive a string and it's going to return unknown. So basically I'm doing JSON.parse with the string, and let's see the usage. So we have here an object when we're doing safe parse with some string, and basically we are receiving unknown. Now there is also a type for functions, so I can actually specify arguments as a function type, but it's not very recommended because it's very generic, so I cannot know what arguments this function is going to get, what it's going to return. So basically I can do anything I want with this function. I can pass it anything I want. And for example, if we say that this function is going to I don't know, console log I, it's totally fine. Yeah, so this is it for the function section. I know it's also was a little bit long. The next one is going to be classes. It's going to be a pretty short one. So I hope you enjoyed, and I will see you on the next section. Okay, guys, the next section is going to be about classes. So I personally don't use classes with JavaScript because I'm working as a front-end React developer. But for all the guys that are using Angular, or even some legacy code with React React, how it's called, React components, React class components. I don't even remember the phrase right now. Also, if you're using Nest.js or something like Mobex, you should be familiar with classes. So I had to add it to our TypeScript course. It's going to be pretty short, pretty straightforward. And let's see some examples of classes, some generic stuff also. So yeah, so let's begin with generics class examples. So let's say that we have here a class of box, which is going to receive a type of T, and we have a private item, which is going to be type of T or undefined. And this is because we don't have a constructor here, so the box, the item can be actually undefined. At the beginning, it will be undefined until we don't use the functions to set the item, to add the item. I call it here. So basically, we have here two functions. So add item is going to take an item, which is going to be a type of T, and it's going to set this item to the item that is passed. And get item is just a getter to get the item, so it can return a T or undefined, and it returns the item from the class. So let's see the usage. We define a box, which is a new box, and we define here that the type of the generic here is going to be a string. Okay, so we define the box, and now we can use the functions. So box.add items, and we add apples. Now we can console log box.getItem. It's going to output apples. And another box, we can define it with the number type. We pass it 42, and we can get the item, which is going to be output of 42. Now let's look at the example of abstract class. So this one is pretty interesting. So basically here we define a base class. So in our case, our abstract class is going to be a shape, and it's going to have one function which is going to be calculate area, and this function is going to return a number. And now we can use this abstract class to use this functionality in our other classes. So for example, we have a class which is called rectangle, which is going to extend the shape we defined over here. And here we have two properties, width and height. And now we have a constructor function which is going to take width and height from the user as parameters. We have to call super here in order to use our abstract class. So if we extend the class, we need to call it in order to have access to this function. And basically we define the width and the height in the constructor. And now we have access to this calculate area function, just like we defined over here, and it's going to return a number. So basically we can return this dot width multiplied by this dot height. From now we can define our rectangle variable, and we can say that this is going to be new rectangle, and we can pass here the width and the height. Now we can use this rectangle.calculate area, and it's going to be, of course, 15, and it's going to come from our abstract class functionality. So basically we can reuse functionality for different classes that we want. So in this case, the calculate area is going to do this thing. All right, so I hope you understand why it is useful. Let's look at static methods properties example. So this one is actually pretty cool. So we can define a class, and we can define static properties. That actually means that we can access these properties without creating an instance of this class. So let's say that we have static pi, it's going to return a number, and this is the number that is going to be returned. And we have a calculate, what is this? Calculate circumference. I'm not even sure what this word is, but I guess that it is calculating the area of the circle. So basically we get here a function. It's going to get a radius as a number. It's going to return a number. So what it does, it's going to return this this calculation. Now, in order to use these methods in our class, I don't have to make an instance of this class. I can just access them by saying mathutils.py, which is going to output our pi value, and mathutils.calculate circumference of 5 is going to output what basically our calculation. So we can define a kind of utility classes that can be accessed without creating instance of a class with the static methods. And basically this is pretty much it for our classes. It's a short one, but it's pretty useful, I hope. And if you have anything to add to this section, please comment below. I would like to hear some more useful stuff with classes, because as I said, I don't use them very much, actually not at all. Yeah, so the next one is going to be very interesting. We're going to dive deep into more generics, and we'll meet in the next section. All right, guys, let's look at the generics section. So we already talked a lot about generics, but now we're going to see some more examples. So let's begin. So the first thing, let's see. So we have this high order generic, and let's look at this one. So we have here a function which is called myMap. It's going to take two generics. So we have here a type and we have a u. And what are the arguments are going to be? We're going to get an array, which is an array of type. And we're going to have a mapper function, which is going to be as it's going to take an item, which is a type of type, and it's going to return the u. So we saw a pretty similar example, I think, in the functions section. So basically we want to take a mapper and we want to create a different array from the array that we pass. And we return, at the end of the function, we return an array of u. So let's look at the function code. So array.map with the mapper. So basically what we can do, we can take this numbers array and we can say const doubled going to be is going to be my map, and then we pass the numbers over here, and the mapper is going to take parameter as x, and it's going to return x multiplied by 2. So basically to double these numbers. So what we see here, let's take a look at the types. So first of all, it's going to take a number. It's going to take a number and a number. So this is the return type. This is the input type, and this is the return type. The array is going to be a number array, and the mapper is going to take an item, which is a number type, and it's going to return a number type. And this is what is this function is going to return, just a number multiplied by 2, of course. So let's look at the types here. Number, this is a number, this is going to return a number. So basically this function is just going to multiply this by 2. Now let's look at the string example. So we have here a hello world, and this function is, this mapper is going to return the length of the strings. So again, we use this mymap, we pass here the strings, and this thing is going to be a string, and it's going to return s.length. So length is going to return the number of the length of the string, basically. So it says here that it's going to return a number and returns the length of the string object. All right, so let's look at the types of my map. And you can see that now the input is going to be a string, the output is going to be a number. So the output at the end is going to be number array. And let's look at another example with objects. So we have name hi and name bye. And here we're passing again the objects, and I want to return the person.name. So each time we get a person, and the person is going to be to have a name property, and we're going to extract the name field from these objects. So basically what we are going to return is a string. So you can see name is a string, and if we hover over this, we can see that, in the end, this function is going to return array of strings. So this was the high order generic. Let's look at some more examples. So non-nullable type. So we are creating here kind of a utility type that is going to return only values that are not null or undefined. So what we have here, we have this non-nullable type, which is going to receive a generic type, and we're going to check. And there is a condition here, so we're going to talk more about conditions in the next section. So t extends null or undefined. We have a question mark. If this thing is true, we return never. Otherwise, we just return t, so just returning the type. So let's see this thing in action. So we have a greet function. We wrap it with, we have a user, so we wrap it with non-nullable type. And we pass, and we say that the generic is going to be a string. And then we can just console log the user. So in this case, this is going to be a string. Now we can, now we can use this greet function, and we can say greet John. It's going to be fine. And if we pass a null over here, it's going to cause an error. All right, now let's look at key of and lookup types. So let's say that we have here an interface of person with all these fields, and let's see, get property. So the function is going to receive again two generics. So we have t and we have k, and basically k is going to extend the key of t. So what this actually means, that is going to be so it's going to be all the keys of the generic option or of the generic object. Sorry. So in our case, it's going to be name, age, email, and isadmin. And the function is going to get the object as t and the key as k. It's going to return the value in the k position. So basically, we check the type, the t, and we return the value of in the position of k. So here in the return, we just take the object and we access the key over here. So let's see it in action. So we define a person. So John Doe, age 25. This is his Gmail, and he is admin. So we can say that name, and we do get property. So we pass the person and we pass the key of name. So this key actually extends one of these object's properties, and it's going to return the name of John Doe, and we can access the age, we can access the email, and now we have actually a type check. So if I pass a key over here that doesn't exist in the object, it's going to throw an error. So even if I pass nothing, you can see that we have already argument of type empty array is not assignable to parameter of type key of person. So it's very nice to have this check for us. So let's get back to what it was. So let's look at another example. So let's say that we want to create a utility type that takes a type and makes it read-only. So let's look at this. So type read-only user is going to be read-only, and here we say key in key of person. So basically all the keys in person, and we return the person key over here. So it's just a key value type. And now when we define this user as read-only user, first of all, the read-only user is going to have, so basically we have all the keys and values from the person type. So I think we should do here something like true or false. So let's say false, for example. And of course now the type is correct. And the interesting thing here is that now we cannot change the fields of the object, because now this read-only user is going to be read-only type, and we cannot modify these fields. Now I want to look at some cool example of actually using the generics to create a function that parses an local storage item. So now let's look at this. It's going to be very interesting. So example of getting item from local storage with generic type. So first of all, we have the function parse from local storage. We're going to take a generic, and the key is going to be a string. So it takes one parameter and it returns the generic or null. So it's also possible that the key doesn't exist in the local storage. So now let's look at this. So const value is going to be local storage.get item with key. So basically, because we are in a node environment, we don't have this local storage, but imagine that we are in the client. So if we have the value, we're going to JSON parse the value as t, okay? Otherwise, we return null. So let's see this interface. So for example, we have the user interface with name and age. And now we can say we create this variable stored user, going to be parse from local storage, and we pass here the type that we want to get. So basically the user, and the key is going to be user. And now we can see that if I hover over this, it can be type of user or null. Okay, let's move to conditional types, so we can close the other thing. And now we already saw some conditional types, and the basic example is going to be very familiar for you already if you went through all the sections. So let's say that we have an animal interface which has a function, and we have a dog that extends animal. So we have animal have be cute, dog have woof, and we have a human that can talk. So for example, let's say that at example 1, so if dog extends animal, we return a number type, otherwise we return a string type. So is dog extends an animal? Yes. So what we're going to get here, let's see. Example 1 is going to be a number. So this type, example 1, is going to be a number because this value, because this, this condition is true. So is human extends animal? In our case, it doesn't. So what is going to be returned? It's going to be a string. So now example 2 is going to be string type. All right, let's see some usage of the conditional types. So let's say that we have two interfaces, one with ID label, one name label. And basically the difference is the label is going to have ID, the ID label is going to have ID of number. The name label is going to be name of string. So we have this type name or ID, and we can get a generic here that extends a number or string. Okay, now let's see what is the condition. So if t extends number, then we return the ID label. Otherwise, we return the name label. So we have this function create label. So t extends number or string. So this is the same as we defined over here. And ID or name is going to be type of t. And it's going to return name or ID, and we're passing the t over here. So we are not doing anything in the code, of course. So imagine that here is the code that returns the proper object. Yeah. So let's say that A is going to be create label with TypeScript, and TypeScript is a string. So what A is going to be from this condition? A is going to be a name label. So let's look at A, and you can see that A is a name label. And if we pass a number, so 2.8, this one is going to be ID label. Okay, let's look at this thing, conditional type constraints. So let's say that we have a type that gets that called a message of, and it extends an object with a message which is going to be unknown. And what is returned is the t type, so basically the type that we're passing at the position of message. And we can do it because we say that t has to extend an object with the message field. So let's look at the examples. So interface email going to have a message which is going to be string, and then we say email message contents, and here we wrap it with the message of email. So we pass the t. So our t at the moment is email, and we can see that this is going to be string because the type of message here is a string. And we can do it with even bigger objects. So let's say that we have multiple fields over here, and what the only condition that we need is that this object is going to have a message field, and if that is going to be if it's going to be true, then we can access the t over here at the message field. So if I, for example, delete this message from here, then we're going to have a problem because let's see the error type even bigger object does not satisfy the constraint message unknown. So we need this object to have a message in order to access the field, the type of it over here. So let's return it. And now the message type is going to be string again because this message thing is a string. So if it was, for example, something else, I don't know, text string. So now this is going to be message type text string. And one more example. So let's look at this. We have a file types over here. So MP3, MP4, and so on. And I want to filter media filter types. So again, we have a generic, and we check if t extends MP3 or MP4, we return the type, otherwise we return never. And now we have media file types. We wrap it with filter media types, and our generic is going to be the file types that we defined over here. And now we can create a constant, so let's say media file, and this should be media file types. So only MP3 and MP4. And now when I pass here a zip file, it's not going to work. So I can only pass here, let's see the options. So I only pass MP3 or MP4, and then this is going to be satisfied. So, all right, so this is it for conditional types. And the last section we're going to go through is the utility types, which is going to be also very interesting. There are some very useful utility types that TypeScript provide you out of the box. So I'll see you on the next session. Okay, we're at our last session, and this one is going to be pretty easy compared to the others because this is just some utility types that TypeScript provides us. So we're just going to go through the most common ones and explain them and just see some examples. So it's going to be pretty chill session. So if you reached this far, you deserve your brain some rest. So this is why I decided to put it in the last session. So let's start. Let's look at the types that we get out of the box here. So first of all, let's look at the awaited type. And what we can actually do is we can even read this description over here. So we can see that this is recursively unwraps the awaited type of a type. Non-promise, promise denables should resolve to never. This emulates the behavior of await. So basically, what this thing means is if we have a promise, something that is wrapped in a promise. So let's say it's a string. So basically, let's look at the B example. If we have a promise of type string, this type is going to be promise of type string. But if we look at A example and wrap it with awaited, then it's going to be just type string. So it basically takes out the value that is going to be returned from the promise. So, and of course we can do it with unions. So it's going to be either a Boolean or a promise with type number. So what is going to be the type of C? The type of C can be a number or a Boolean. The next thing, let's look at partial. So let's say that we have a to-do with title and description, and basically we have an update to-do function, and that takes a to-do and fails to update is going to be wrapped with partial to-do. So basically, partial to-do is going to it's going to make all the to-do fields optional. So let's look at this. So we have to-do one, so title, description, and we have to do update to do. And this was very strange. I got for some reason a type error in the to do, but anyway, I just changed it to do two. There was some TypeScript bug, so now it's totally fine. So let's see. So let's look at this again. So update to do is going to take to do one, basically this to do that we created, and I want to update. So we are passing here object with description. With just a new description, and this is totally fine because we are using partial over here, and partial is going to be just as it says, a partial part of this to-do interface. Now let's look at required. So required is basically the opposite. So all the optional fields in the interface are going to be required. So as you can see over here, let's say that we have an object which is going to be of type props, and this is totally fine because all this A and B are optional here, so I can just specify the object with A. But if I wrap it with required, I cannot just do I cannot just say A equals 5. I need to also provide a property for B. Now, read only, this is also very straightforward. So let's say that we have to do over here with title string, and to do, again, for some reason, it's, I need to change this because I have some overlap in TypeScript, but never mind about that. We are just going to see the example of read only. So read only to do, we cannot change the properties of this object. Now let's look at the record. Record is a pretty interesting one. So let's say that we have interface of cat info, which is going to be age and breed, and we have a type of cat name, which can be Miffy, Boris, or Mordred. And basically we have the cats object over here, and it's going to be a record of cat name. So cat name is the key and cat info is the value. And as you can see, we are using the names over here. So these are the keys, Miffy, Boris, and Mordred. And here we have the values. So it's basically the record actually takes a key and a value and combine them together. And of course, we can, and of course, we have access to all these cats by their key. So the next one is pick. So we're going to take a type and keys. So let's say that we have to do interface like this, and we have a type to do preview, and I want to pick the title and the completed. So let's look at the partial to do that we created. So to do preview is going to have just title and completed. So just the parts that we described over here. Yeah, so basically that's it for pick. And we have also omit, which is, as you can guess, it's the opposite of pick. So let's say that we have this interface of to do, and we want to omit the description from this interface. And we have now omitted, to do, which is going to be omitted preview. And now we can create it this to do without the description property. So we have also exclude the differences. Now we are passing a new union type. We're excluding a member of the union. So let's say that we have A, B, and C, and we want to exclude A from the union. So now T1 is going to be B or C. And what's going on over here? T2. So it's going to take either a string or a number or a function, and I want to exclude the function. So now this is going to be a string or a number union. So another thing that we can use to exclude is I can specify properties inside an object. So let's say that we have a shape with circle, square, and triangle. And what I want to do is to exclude an object with kind of a circle. So now this T3 is going to be either a square or a triangle. So extract is, as it says, the opposite of exclude. So we're going to take a type and a union over here. So there are actually two properties over here. So we have a comma here. So this one is going to be the type, and this one is going to be the union. So we extract A or B or C from A or F. So let's look at this. So basically what it does in simple words, it check what are the common types for both of these things. And for this one, we have only A over here and A over here. And this is why this is going to be A. So the same principle, we check if what is common between string, number, and a function, and the function. So what is common between them is the function. So T5 is going to be this function that returns void. So there is also a non-nullable type out of the box. So non-nullable. So we pass here all these options, and what is going to be left from this is only the string. So if we hover over this, sorry, there is also number. So there is a number and a string, and undefined is nullable, is actually falsy. So this is why we are staying only with string and a number. And in this case, what we're going to be left with is only a string array, because null and undefined are both falsy. So let's check. Yeah. So T7 is going to be a string array. Now let's look at this. This one is pretty interesting. So parameters is going to take all the arguments that we get from the type. So let's see. here we have a function that is taking nothing and returning a string. So parameters is going to be an empty array because there is no parameters that are passed. And in this case, we have a generic here, and we pass an argument of t and returning a t. So the parameters in this case are going to be argument, and it's going to be type of unknown. So let's say that we get rid of this t over here, and let's say that, for example, let's pass string, and I don't know, let's return a void or something. So let's look at t9 again, and now we have the parameter arg is going to be type of string. Yeah, so this is pretty much similar to what I did. So we have an arg here. It's going to take a and b, and it's going to be this object with a and b as numbers, and it's going to return void. So now if we check the parameters of t10, so what we're going to get is this arg, and it's going to be this object of a and b. And last but not least, we're going to check the return type. So again, we take a type over here, and what is, so basically we check. So for example, we have this type of a function. So it's going to return, an object with a and b. And if we check the return type of t12, it's going to be the object with a and b. Now, if for example we change this one to void, now if I check the return type of this, we can see that this is that t3 is going to be actually void. And the same I can do, I don't know, for null. So now t13, sorry, is going to be type of null. So this one is pretty cool. It actually returns the exact return type that is coming from the function. Alright guys, this is it for our TypeScript course. I know it's a little bit overwhelming if you're a junior developer and you see this stuff, but believe me, it's not that difficult. You just need to just practice a little bit, and it will make much more sense. So I hope you enjoyed, I hope you learned something new from this. And if you liked this, please like the video, subscribe if you're new here, and I will see you in the next one. Bye guys, and thank you for watching.